Hello, in this video we're going to look at differentiation, and we will do it in such a way that when the equation given to us in this condition like this, where you have a situation where you have an function multiply another function, and if you have learned about product rules, so we know that commonly when there is two functions multiplying each other, we will do product rules. But however, for the purpose of this video, we're going to give you two examples. So the first one is we're going to demonstrate for us if we have difficulties remembering product rules. Okay, but the situation allowed us by expanding the brackets, something familiar to you, and after expanding the brackets, the equation has become terms. Then only we start doing the differentiation. Okay, and then the second method, of course, is the product rules, and we will do that as per the regulation requires. Okay, and please be careful. We can do this option if the question did not explicitly mention what method they want. If the question explicitly mentioned use product rules, then we have to obey the instruction, then we need to only do the product rules. Okay, so with that cautions in mind, let's move on to see these two examples. Okay, the first example I stated here, differentiate y equals x multiply another function called x plus 4. Okay, in this situation, let's say if we are given that, so what we can do is, let me copy down the question, x plus 4, and now we can expand it first. In other words, we do not do differentiation yet. So what we do, we just expand the bracket. So we just expand and bring out the individual terms in this manner. Okay, so we have just expanded out. Then only from these steps onward, we do differentiation. So please pay attention at the change of the subject. Previously, we still stay with the equation in y. Okay, and then now we start to do the differentiation by term, and then so we learn that the index multiplied to the front, and then the index for minus 1. So that will give us 2x. Then we do the same thing here, differentiate this, then 1 minus 1 becomes 0. So 4 times 1, and that is the answer. Okay, and this is the simplest form. Okay, this is the option if the question do not explicitly say that you must use product rule. Let's go to the second approach. If the questions explicitly mention that you need to use product rule to differentiate this, then we will just recall back the key idea about product rules is taking turn to differentiate and taking turn to rest. What does that mean? Let's move on to put it. Let's call this as the green function, and let's call this as the purple function. All right, so as I go on, I will just mention to our remembrance what is required by the product rules. Okay, the very first thing, okay, you can keep this at rest. Okay, so I'm just copy paste. I do nothing about the green function. Then now I go to differentiate the purple function. So what we do is that, okay, we keep the x, and then now we differentiate the purple, and that give us x, differentiate x, so we got 1, differentiate 1, you got nothing left. Okay, so that is the purple function. And then now the product rule also tells us we need to plus. Okay, then using the, okay, so I'm going to keep the purple one at rest, all right, because purple has been differentiated, so I'm going to keep it at rest, and then now just put in there x plus 4. This is what we meant by just leave it at rest. That means we do not do anything, we just copy and maintain its function. Then now we go to the green function, we differentiate that, so we got 1. Okay, so that is the, we have done, finished complete the product rule. Okay, so I just note down here just for some of us that we may want to remember them. Keep or maintain. Okay, let me just use the word maintain. In other words, you just copy the original, maintain, and then you come here to differentiate the purple, and then you maintain the purple, and now you differentiate the green. So it's, in other words, is the idea of taking turn to differentiate and taking turn to be kept, maintain the same. Okay, once you have done that, so you have accomplished the product rules, and now you will follow by rearrange it to um, simplify that. So x times 1, so you got x. Then here you expand this one. 1 times x times 1 positive 4, you got x plus 4. And combine them together, you got 2x plus 4. Okay, so you notice both of the methods will land you at the same answers. Okay, so you see this, the answer is 2x plus 4. Same thing here, 2x plus 4. Got it? Okay, let's go to the second example. Again, also if there is no explicit instruction for you to use product rule, let's demonstrate that. So again, so let's rearrange them by expanding the 2x times 3x, you got 6x squared. Then here you got 2x times 5, you got 10x. Okay, you expand them into terms. So now you go to differentiate it. Now change the subject now to gradient. So dy dx, then differentiate this. Alright, so you got 12x. Then differentiate the 10x, you got 10. There you go. Okay, so now let's go to demonstrate for us the two functions in the product rules. All right, again, taking turns to be kept, maintain the same, and then differentiate. And then in the between is an addition, add it up. So now let's go, and so dy dx, okay, so just to help us to remember, so I'm just going to, we were going to do something with the purple and the green, and then the green and the purple. All right, so however, if you may not have to always keep in this order, okay, you can always do it the other way if that is convenient to you, but as long as you maintain taking turns, differentiate ones and stay at rest, plus differentiate the others and stay at rest. All right, so as long as you take turns. Okay, so I will just keep to this pattern because, well, to me, I find it is easier because it's kind of like used to it, or because of the symmetry look. All right, so whichever method. So now I'm going to keep the 2x. Okay, keep the 2x and then differentiate the 3x plus 5. So you got 3. Okay, this time I'm going to maintain the 3x plus 5. Then differentiate the green one, so I get 2. Okay, so done. Then followed by simplify 2x times 3, awesome, 3x. Then here you got 2 times 3x, expand the bracket, so you got 6x, and then 2 times 5, you got positive 10. Okay, combine the like term, 6x and 6x, you got 12x, and plus 10. That's it. Okay, so if you take a look at the final results, okay, they are the same. dy dx, so the result is 12x plus 10, so 12x plus 10, which is dy dx. Okay, so that's all for this video. So looking forward to see you again. We're going to demonstrate more of the product rules and then until you get mastery of the skill. All right, so until then, bye-bye.